Good morning, students. In continuation with Z transform, remaining properties of Z transform, we will discuss remaining properties of Z transform. Differentiation in Z domain or Z transform. If Z transform of Xn is X of Z, then Z transform of n multiplied by X of n is given by multiplication of minus Z, and derivative of Z transform in Z domain. And according to the definition of X of Z is given by summation X of n Z raised to the power minus n. If we differentiate both sides, we get this expression, and here if we differentiate Z raised to the power minus n, we get minus n multiplied by X of n, Z raised to the power minus n minus 1, and Z raised to the power minus n minus 1 can be written like this. Here we write this, and if we take Z raised to the power minus 1 out of this summation sign, then we get the expression like this. And this expression is the Z transform of n multiplied by X of n. So we can say that Z transform of X of n is given by multiplication of minus Z and dx or derivative of Z transform of Xn X of n. Z transform of n X of n is given by minus Z derivative of Z transform. So we can say that multiplying a sequence in time domain by n is equivalent to the multiplying of derivative of its Z transform by minus Z in Z domain. Find out the Z transform of X of n. X of n is given by given expression. The given expression is this, and it can be written as X of n is equal to x1n plus x2n and x3n. First we take x1n. x1n is half impulse function of xn plus 1. And we know that Z transform of impulse function is 1. And if we use shifting property, we get Z transform of delta n plus 1 is given by Z raised to the power 1. Z raised to the power 1 is for this term, and Z transform of impulse function is 1. So Z transform of half impulse function or delta n plus 1 is given by half multiplied by Z. Next sequence is x2n, and x2n is given by this expression, and we can write this expression like this. Half raised to power minus n can be written as 2 raised to the power n divided by 1 raised to the power n, or we can write 5 multiplied 2 raised to the power n u of minus n. And we know that Z transform of u of minus n is given by 1 minus z, and ROC is interior of circle having radius 1. So z transform of a raised to the power n u minus n is given by 1 by 1 minus z by a. Here we use scaling property of z transform. So ROC is given by mod of z is less than mod of a. In this case, value of a is 2. So if we replace value of a by 2, we get the final z transform of given transfer function, which is 5 divided by 1 minus z by 2, and ROC is absolute value of z is less than 2. Then x of 3 is given by u minus n minus 1, and z transform, we know that z transform of u of minus n is given by 1 minus 1 by 1 minus z, and ROC is mod of z is less than 1. Using time shifting property, we can write according to the time shifting property, we can write x z transform of x of n minus k is given by z raised to the power minus k x of z. X of z is given by 1 by 1 by 1 minus z. So we can write z transform of u minus n minus 1 is given by z raised to the power 1 multiplied by 1 minus 1 by z, and ROC is less than, or ROC is anterior part of circle having radius 1. So x3 of z is given by z divided by 1 minus z, and ROC is given by this. So combined z transform is given by half z plus 5 divided by 1 minus z by 2 plus z divided by 1 minus z, and ROC is combined ROC is anterior part of circle having radius 1. Next question is, using differentiation property, obtain the z transform of unit ramp sequence. Unit ramp sequence is given by n multiplied by un, and we know that according to the differentiation property, z transform of nxn is given by minus z derivative of x of z, where x of z is the z transform of x of n. In this case, x of n is u of n, and we know that z transform of unit step function is given by z divided by z minus 1, and ROC is greater than or exterior part of circle having radius 1. So according to the definition of the definition of their differentiation property, z transform of ramp function is given by minus z multiplied by d by dz, and this is the z transform of un. Then differentiating this z by z minus 1, z multiplied by differentiation of z minus 1 whole minus 1 raised to the power minus 1 plus z minus 1 whole minus 1 dz by dz. So we get this expression, and solving this expression we get z divided by z minus 1 whole square, where ROC is greater than 1, or ROC is exterior part of the circle having radius 1. Similarly, obtain the Z transform of signal x of n is given by n a raised to the power n un. Here assume that a raised to the power n un is equal to x1n. So xn is given by n multiplied by x1n. Using differentiation property, here x1z is the z transform of simply x1n, and x1n is this. So z transform of a raised to the power n un is given by z divided by z minus a. Using scaling property, ROC is absolute value of z is greater than absolute value of a. So by putting the equation, we get z transform of n a raised to the power n un is given by this expression, means differentiation of a raised to the power n un, differentiation of z transform of this sequence, and z transform of a raised to power n un is given by z divided by z minus a, and if we differentiate this term, we get minus z multiplied by minus a divided by z minus a whole square. So we get the z transform of n a raised to the power n un, which is equal to az divided by z minus a whole square, and ROC is exterior part of circle having radius a. This is the standard z transform, and we can easily find, if you have to find out the value of n un, then put a is equal to 1, means z transform of n un is equal to z divided by z minus 1 whole square. Here we put value of a is equal to 1. Then convolution of two signals. Suppose that z transform of x1 n is given by x1z and z transform of x2 n is given by x2z. Then find out the z transform of convolution of x1 n and x2 n. Suppose that x1 n is equal to x1 xn is equal to x1 n convolution x2 n. So xn is given by summation k from minus infinity to plus infinity, x1k, x2 n minus k according to the definition of mm, convolution. Then according to the definition of Z transform, if we take Z transform of both sides, we get x of z is equal to summation from minus infinity to plus infinity, summation minus infinity to plus infinity x1k x2 n minus k multiplied by z raised to the power minus n. Here we put the value of x of n. Then rearranging these summation terms, we take this term out of this summation sign, and x z raised to the power minus n can be written like this or like this. And in this case, we take z raised to the power minus k out of this summation sign. X2 n minus k multiplied by z raised to the power minus n. This z raised to the power minus n can be written like this. And then we take z raised to the power minus k out of this summation sign. Okay. And in this we put n minus k is equal to m. So we get summation x1k x of z is equal to summation x1k multiplied by z raised to the power minus k multiplied by summation x2 m and z raised to the power minus n. And these are the z transform of x1k sequence and x2m sequence. So we can say that x1n convolution x2n is equal z transform of x1n convolution x2n is equal to x1z multiplied by x2z. Means convolution of two sequences in time domain is equivalent to the multiplication of its z transform in z domain. Yeah. Same as in case of z Laplace transform or Fourier transform. Then find out the linear convolution of x1n and x2n using z transform. x1n is given by this and x2n is given by this expression. And according to the linear property, z transform of convolution of two signals is equal to the multiplication of their z transform in z domain. First we find out z transform of x1n. x1n is given by this expression and z transform of this x1z is given by summation x1n z raised to power minus n, and here value of n is 0, minus 1, minus 2, and this is n is equal to 1. So range is decided by n raised to power minus 2 to 1 is given by x1n z raised to power minus n. So if we expand this summation, we get expression like this. So we get the z transform of x1n. x1z is equal to z square plus 2z plus 3 plus 4z raised to power minus 1. And then determine the ROC. Put the value of z is equal to 0 and z is equal to infinite. First, you put z is equal to 0. You get value of x1z is infinity, which is not allowed. Similarly, when you put z is equal to infinity, infinity plus infinity is equal to infinity. So ROC is entire z plane except z is equal to 0 and z is equal to infinite. Then we obtain z transform of x to n. Here n is equal to 0, minus 1, minus 2, 1 and 2. So limit is from minus 2 to plus 2. X to z is equal to summation minus 2 to plus 2 x to n z raised to the power minus n. So value, if we expand this summation sign, we get x to z is equal to z square plus 2z plus 2z raised to power minus 1 plus z raised to the power minus 2. Then determine the ROC. For z is equal to 0, we get infinite, so z is equal to 0 is not allowed. Similarly, when you put z is equal to infinite, you get the value of x to z is equal to infinite, so z is equal to infinite is not allowed. So ROC is entire z plane except z is equal to 0 and z is equal to infinite. And we know that x of z is equal to x1z multiplied by x2z. So we multiply the value of x1z and x2z, we get the final value of xz is this, and in this case value of z is 0 or value of n is 0 because z raised to the power 0 is 1. So n is 0, minus 1, minus 2, minus 3 and minus 4, 1, 2 and 3. So we expand this expression like this, and here we find out the value of x minus 4 is 1, x raised to the power x minus 3 is 4, x minus 2 is 7, x minus 1 is 12, x0 is 13, 1, x1 is 8, x2 is 11 and x3 is 4. So we get the value of sequence x of n is given by 1, 4, 7, 12, 13, 8 and 11 and 4. And this arrow indicates the value of sample when value of n is 0. Then initial value theorem, if x of n is a causal sequence, then its initial value is given by x of 0 is equal to limit z approaches infinite x of z. If x of n is causal sequence, then its initial value means x of 0 is given by limit z approaches infinite x of z. According to the definition of z transform, x of z is given by this expression. And if x of n is causal sequence means right-handed sequence. It means that its limit changes from n is equal to 0 to infinite. And if we expand this expression, x of 0 z raised to the power 0 plus x1n z raised to the power 1, when n is 1 z raised to the power minus 1 plus x2 z raised to the power minus 2 and so on. This x raised to the power minus 1 is written as 1 by z, and if z is approaches 0, it means this term turns to be 0. Similarly, this term turns to be 0 and this term also turns to be 0. So we get limit z approaches infinite x of z is equal to limit z approaches infinite x of 0. Similarly for this expression and this, because in this case this is 0, so this term is 0, this term is 0, and all the terms are also 0. So we can say that initial value of x of n or x of 0 is given by limit z approaches infinite x of z, and initial value is given by this expression. Then final value theorem, if x of n is given by x of z, means if z transform of x of n is given by x of z, then final value theorem x of infinite is given by limit z approaches 1 z minus 1 multiplied by x of z. According to the definition of z transform of x of n is given by this expression, and if we consider x of n minus x of n minus 1, then z transform of this is given by simply by this expression. So z transform of x of n minus z transform of x of n minus 1 is given by this expression. Here x of z n is written as x of z, and x of z transform of x of n minus 1 is written as, by using time shifting property, it is written as z inverse z raised to the power minus 1 multiplied by x of z. If we write the z transform of both sequence, we get this expression, and if we simplify this expression, x of z multiplied by 1 minus z raised to the power minus 1 is equal to summation n n is equal to 0 to infinite x of n z raised to the power minus n minus summation n raised to the power 0 infinite x of n minus 1 z raised to the power minus n. So we can write this, if z approaches to infinity, so z raised to the power n is written like this, and value of z approaches to 1, it means that 1 by 1 raised to the power n is 1. So here we can write this term as 1. So when in the case of limit, when limit in case of limit z approaches to 1, summation x of n minus x of n minus 1 multiplied by z raised to the power minus n can be written like this. And if we substitute the value of n, when n is 1, when n is m, x of m minus x of m minus 1, in the next value of n is m minus 1, so x of m minus 1 minus x of m minus 2. Similarly, if we write when n is equal to 0, when n is equal to 1, x of n, x of 1 minus x of 0, and when n is equal to 0, x of 0 minus x of minus. So this term is cancelled by this term. Similarly, all terms are cancelled, and here we get only limit m approaches to infinite x of n, or we can write x of infinite or final value of x is equal to limit x of n where n approaches to infinity, or limit z approaches infinite 1 minus z raised to the power minus 1 multiplied by x of z. Question. Find the initial and final value of x1 if z transform of is given by x of z is given by 2 divided by x z raised to z square plus 1 by x z minus 1 by 6. So according to the definition of initial value theorem, x of z is given by this, and if we substitute the value of z, we get the initial value of x of n or x of 0 is equal to 0. Similarly, according to final value theorem, x of infinite is given by limit z approaches 1, z minus 1, x of z. Substitute the value of x of z, and if we calculate the value of, since this is a quadratic equation, find out the roots of this equation. So final value of x of n is given by limit z approaches 1, z minus 1, 2 divided by this. These are the quadratic equation is written in terms of root. So here, if we put z is equal to 1, we get the value of final value of x of n is 0. Okay, time is over. Thank you. And